Hello guys, so in this video we're going to find out how to find the vector that's parallel with you, called u perpendicular. So we're going to find the u perpendicular vector, and here we're given this formula that u perpendicular is equal to u minus u parallel. So what does that mean? It means the first step we have to do is we have to find u parallel. If you don't know how to find u parallel, I have a video on that in this playlist for Calculus 3 on how to find a u parallel vector. But for this one, we're going to get straight to it, u perpendicular. So the formula for u parallel is, off the top of my head, I should know this, is equal to u dotted with v divided by the magnitude of v squared times a vector v, sorry. And for v's, I put these little distinctions so that way you distinguish it from u. So this is how we find u parallel. So the first step we're going to do is we're going to go ahead and take the dot product. So we're going to find u dotted with v. So we're going to take the dot product of these. The dot product. So in doing so, if you don't know how to find dot product, I have a video on that as well. U dotted with v is equal to 1, 4, 7 dotted with 2, 3, minus 1. And in doing so, when we take the dot product, we multiply element by element, so we get, and then we add the terms together. 4 times 3 plus 7 times negative 1. And we do this, we get 2 plus 12 is 14. 14 minus 7, 7. This is our dot product. Our dot product came out to be positive 7. So now the next step is to find the magnitude of v squared. So we're going to go ahead and do that. And to find the magnitude of v squared, all we're simply going to do is take this vector v, find its magnitude, and then square it. And if you don't know how to find magnitude, I have a video. I mean, plenty of my videos do that, but it's a very simple concept, so I'm going to do it real quick. So the magnitude of v squared would be 2 squared plus 3 squared plus negative 1 squared. Take the square root. This is our magnitude. But then we square it. So 4 plus 9 plus 1, 13, 14. Yeah, 14. So this comes out to be 14 inside a square root, but we're squaring it. So since we have a square right here, so the magnitude of v squared is equal to positive 14. Also, you can't have something negative. So if you have something negative, then you messed up. But anyways, this is our magnitude of v squared. So now the next step is to find u parallel, given this formula right here, or given this formula. So to find u parallel, u parallel would be equal to u dotted with v. So what do we get? We got 7 for that value, divided by the magnitude of v squared. And for that value, we got positive 14. So 7 divided by 14. And then we're going to multiply it by our vector v. So our vector v is 2, 3, negative 1. The next step is we could take this a step further. So we know 7 over 14 is equal to 1 over 2. So we're going to go ahead and simplify this. So we have 1/2, 2, 3 minus 1. And then we go a step further. And then we just simply simplify this expression by distributing the 1/2 to every term. So 2 divided by 1/2 would just be 1. 3 over 2. And then negative 1 divided by 1/2 would be negative 1/2. So now we have our u parallel component. So the next step is to find u perpendicular. And every time you see this symbol, it means perpendicularity. So now we're finding u perpendicular. And we know u perpendicular is equal to this formula right here. So u minus u parallel. So basically we're just going to take our vector u, which is right here, and we're going to subtract it. We're going to do vector subtraction with our vector u parallel. So we're going to go ahead and do that right now. So u perpendicular would be equal to our vector u, which is right here. So our vector u is 1, 4, 7 minus our u parallel vector, which is 1, 3/2, negative 1/2. And performing this arithmetic, our u parallel vector, after doing vector subtraction, so we just subtract element by element, we get 1 minus 1, we get 0. 4 minus 3/2, we get, what is it? 4 minus 3/2 is 1.5, which would be the same thing as, no, it's 2, which would be the same thing as 8 divided by 3, so it's 5 over 2. And then 7 minus 1/2, so 14 over 2 divided by 1 minus 1 over 2 minus negative 1 over 2, so we're adding, so this would be 15 over 2. Be careful with the sign convention, but this is basically how you take a parallel vector or a perpendicular vector. So first we have to find the u parallel, which you do by applying this formula. So we dotted the two vectors, then we find the magnitude of v squared. Then we distribute it with our vector v. Then after that, for u perpendicular, we just do subtraction, vector subtraction of u minus u parallel. So we just subtract each component separately. Watch out for this minus sign, because 7 minus negative half is the same thing as 7 plus 1/2. So 14 over 2 plus 1/2. And we got 15/2. Thank you for watching. I hope that was helpful. Hello guys, so in this video we're going to go over how to find a vector that's perpendicular to our u vector. So here we're given this formula, u perpendicular. Every time you see this notation of an upside down t or a right angle, it means perpendicular. U perpendicular is equal to u minus u parallel. So the first step we do is we got to find u parallel. So that's the first order of business, is to find u parallel. And how do we do that? If you don't know how to find u parallel, I have a video on that. But anyways, the formula for u parallel is equal to u dot v divided by the magnitude of v squared. I'm going to put this on my v's. Times v, and times the vector v. And you're supposed to get a vector whenever you compute the u parallel, not a scalar. So without further ado, the first thing we need to do is find the dot product of u dot v. So the dot product. So to compute the dot product, I have a video on that as well, but basically we just multiply each term by element y. So x with x components, y with y components, z with z components, then we add the terms together. So u dotted with v is equal to u, so 0, 20, negative 17, dotted with v, so 108 minus 19 minus 17. And then when we dot these, we get 0 times 108 plus we add each term. 20 times negative 19 plus negative 17 times negative 17. So in doing so, this term zeroes out. 20 times negative 19 is minus 380. And then negative 17 times negative 17 would be plus 289. So whenever we combine these terms, we get, 91 in the negative direction, so negative 91. So this is our dot product. So now the next step would be to compute the magnitude of V squared. So we take our vector V, which is right here, 108, negative 19, negative 17. We square the terms, add them together, take the square root, and then we square it again. So the magnitude of V squared is equal to 108 squared plus negative 19 squared plus negative 17 squared, and then all this inside a square root, but then we're going to go ahead and square it. So in doing so, for this one, I definitely need my calculator because I'm not squaring that 108 in my head. So let's see. 08 times 108, that number plus that number plus, so 12,314. So I got 2,314. So I'll go ahead and put it up here. So I got 1, 2, 314. I'm gonna draw a line to separate these inside a square root, but we're squaring it, so this is actually just equal to this number I have. So this is 12,314. 12,314 is our magnitude of V squared, and U dot V is equal to negative 91. So now the next step would be to find out the U parallel component. So in doing so, okay. Our U parallel is equal to our U dot V, which is negative 91, divided by 12,314, dotted with our vector V. So 108, negative 19, negative 17. I'm getting that from this formula right here. And whenever we compute these numbers, we get some very, very high weird numbers that I'm just going to use my calculator for. So let's see. So 108 times negative 91. So U parallel is equal to negative 9,828 divided by, and yeah, you could go a step further and reduce these, but I'm not going to for simplicity's sake. I'm just going to go ahead and leave whatever the calculator tells me. So positive 1729 divided by 12,314. Then the next term will also be positive as well. And this is our u parallel. So now the next step we have to do is we're trying to find u perpendicular. So put a line. And how do we do that? Well, we have a formula right here. U perpendicular is equal to u minus u parallel. So to find u perpendicular, all we'd simply do is just subtract u minus u parallel. So our u vector is this one right here. And we're gonna subtract it by u parallel. So u perpendicular is equal to our u vector, which is 0, 20, minus 17, minus our vector, that's u parallel. Our u parallel vector is those really big numbers that I'm not going to simplify for now. Okay, I ran out of room. Okay, so just know these are all, u parallel is this right here. So now computing u perpendicular, we get u perpendicular is equal to 0 minus this number, negative 9828, divided by 12314, comma 20 minus this number, and then all I'm simply doing is just showing the subtraction step by step. Negative 17 minus 1547 divided by this number. And the hardest part of this one really is just computing it, just because we have really huge numbers, but it's a very easy problem. So the first one will just be 0 minus negative that, so it's just going to be positive. The next one would be 20 minus that number, which I'm going to need my calculator for. And for this number, we get for the next one, we get this number, 2044.51 divided by, and then our next term we get 885. And this is our final answer. Big computation, but very easy. So basically just follow the steps. So the first step is we find our u parallel. We do that, we take the dot product, then we find the magnitude of v squared. Then in doing so, we compute our u parallel vector, which comes out to be this thing right here. The next step is we find u perpendicular simply by just performing subtraction of u minus u parallel. And in doing so, we get these really big numbers, but these numbers are the correct answer. These numbers right here. Thank you for watching. I hope that was helpful.